The forecast package was created by Ryan and Niesman. The package has forecasting data. So here's loading the library. And the first demonstration of this package will be how it calculates moving average. So moving average is a calculation to analyze data points by creating a series of averages of different subsets of the full data set. A moving average is commonly used with time series data to smooth out short-term fluctuations and highlight long-term trends in the data. It is often used in technical analysis of financial data, like stocks, which is what I'll be demonstrating today. So here's just reading the data set, which is the Dow Jones weekly closing from July 1971 to August 1974, and just making it into a time series right here. Just specifying the start, end, and frequency. And then calculating the moving average is as simple as calling the MA function on the time series, and the order parameter specifies how many elements you want to average to get the moving average, which is here. And you can plot it, so I plotted the moving average here, and over it I plotted the actual data points in red.
Next, I'll be going over time series decomposition in R. So the first thing we do is load in our data set, which is this births data set. We do some basic commands to look at what's inside the births data set, and then load the births data set into a time series object that can be used by R to decompose the time series and do other mathematical calculations. So the births data set is all the births in New York City from January 1946 to December 1959, and this is kind of what the time series looks like. So we can decompose the time series using the decompose function in R. There are two types of decompositions you can do, additive and multiplicative, and I'll be comparing both of those right now. So this is what the decomposition looks like using the additive argument, and this is what it looks like using the multiplicative argument. The randomness plot below kind of tells you how well this series is being decomposed. So what decomposition does is it categorizes the time series into different categories so you can better separate the patterns and behavior of the time series. This helps us understand the data better, and in some cases we can make better predictions. The last type of decomposition that you can do in R is STL, which is seasonal decomposition of time series by Loess, which is they just use a different method to decompose the time series. You use the STL library, and then over here you can see what the decomposition looks like plotted.
Finally, I'm going to be doing a weekly forecast where we read in the gasoline data set, which is the U.S. production of gasoline from 1991 to 2005. And then after that, we utilize the time series function and set the frequency to 365.25 divided by 7 to account for 52 weeks in the year. We then created the data frame with the alkaline information criterion for the time series object. This measure is a relative quality of statistical models for a given data set. We apply the list function. Next, we are going to shuffle through the data to make the prediction using the AutoArima function. AutoArima function returns the best ARIMA model according to the AICC. The function conducts a search over possible models within order constraints provided. ARIMA models, in theory, are the most general class of models for forecasting a time series. They can be viewed as a filter that tries to separate the signal from the noise, and then the signal is extrapolated into future to obtain forecasts. Next, we create the final forecast data set utilizing the best data frame and the Fourier function. That returns matrices of dummy variables suitable for use in ARIMA. We set it predicted to 104 weeks worth of data. And then we plot the FC, and the blue portion of this graph is indicative of the predictions for the next 104 weeks in 2005 to 2007.